Hey, everybody. Thank you so much for your time. My name is Mason. I'm one of the founders of Rare Earth Genomics, one of the sponsors of the Industrial Hemp Program here at A&M. Today, we're really excited for you to meet more of our team. I just want to pat the guys on the back, and girls, actually. They've been an incredible part of our success, just their passion for their plant, their skills, their expertise. Over the last several years, we're actually entering the fourth year of the program. We've really grown together. They've graduated, they've got their degrees, they decided to stay on with us. So we're really thankful to them for forming sort of the core of the research program here. They wanted to share some of the details of what they're working on, what they're passionate about for this plant in this industry. And we actually just signed a landmark, 5-year agreement with A&M that we're sticking around. So we're all, the core of our team is staying together, and we're really excited to have you all here and learn about what they're working on. So I'll pass it off to MJ.
Thank you so much, Mason. So my name's Meredith Clay, but I'm also known by my peers as MJ. I'm actually from Baltimore, Maryland. I'm not a Texas native, but I've been working with cannabis since Maryland legalized medicinal cannabis in 2015. I've been at A&M since my undergraduate career in 2021, and that's actually when I joined the Industrial Hemp Breeding Program with Dr. Russell Jessup. I've had the greatest opportunities working with the program, learning many different skills throughout my career. I also have to thank Soil and Crop Sciences and Mason Rare Earth Genomics for allowing us to have this opportunity to work with cannabis. It would not be possible without them. Throughout my research at A&M, I've been working on trying to breed cannabis to have better agronomic traits so that we can make the efficiency better in the industry. We've been having problems with plants having drought and heat tolerance, as well as growing in our thick clay soil of Texas. In addition to growing and breeding for better agronomic traits, I've been working on better propagation techniques with cannabis, as well as using petioles and optimizing our overall techniques. Other things I've been working on is trying to categorize and the uses of trichomes. This can help with not only the medicinal industry, but as well as the industrial industry. And working with this has been so much fun. I've been gaining a lot of different techniques as controlled environments, outdoor environments, different clonal propagation techniques, different breeding techniques, basically everything cannabis. It's been really a dream come true. And with the Industrial Hemp Breeding Program, we've been working on a lot of different aspects. It was founded in the spring of 2020 with help of Mason and Dr. Russell Jessup. What we've been working on is not only just breeding for the plant, but also introducing different industrial components. This has included working with different aspects of how we can use this plant, as Dr. Jessup refers as a biorefinery. This allows us to use this plant for every aspect to not only combat different industrial purposes, but also medical purposes and even the food industry. Some of our students have been working really hard in optimizing this plant. With our breeding, we've been working on with Ezekiel Soto, a PhD student, with inbreeding cultivars so that we can get consistent genetics. This is revolutionary in the industry because if you talk to any plant grower of cannabis and they plant seeds, they will tell you that the plant is all over the place. You have no idea what it's going to give you. So Zeke's work with making inbred lines has been amazing for the cannabis plant. Something else we've been working on is PhD student Christopher Garcia. He has been working on making tetraploids and triploid plants. This has been incredible for industrial purposes. This is not only increasing fiber length, but increasing seed size. This also helps with aspects for the food industry. I'm sure we're all familiar with the fact that cannabis has high omega-3s and 6s in its seeds. If we can increase seed size, we can increase possibly the content of the nutritional value of this plant. Other breeding techniques that we've been working on is trying to find cannabinoid-free hemp. This has been worked on by master's degree by Teja Sri Bengal. She's been doing incredible work with this plant, trying to find different ways that we can breed and mutate so that we can have cannabinoid-free hemp. This will allow farmers to have exactly no worries when they're growing the plant because hemp farmers are under scrutiny if their plant becomes hot, having over 0.3% THC in the hemp plant. Other aspects other than breeding has been going to the industrial side. PhD student Joshua Van Dyke has been working on bast and fiber techniques. This has been helping with trying to figure out how we can combat different polymers such as plastic, which have become harmful for not only environment, but also ourselves. If we can be able to discover different ways with nanocellulose and other techniques to overcome these harmful polymers, we can not only help ourselves, but the planet. As well as going into the industrial side, PhD student Ian McGrath has been working on different ways that we can create an environmentally friendly pesticide. He's been looking into the research and applications of natural plant components and how those can actually combat our current day pests, and not only in the hemp industry, but the entire agricultural sector. This has been revolutionary in not only helping our plants, but helping the plants that we consume and the animals and our entire earth as a whole. Not only industrial aspects that we're going into and breeding at the Industrial Hemp Breeding Program, we've actually started to delve into the food industry. Undergraduate technician researcher Lauren Greer has been working on different ways that we can create food products from cannabis. As I said earlier, seeds have a high amount of protein, fiber, and omega-3s and 6s. She's been researching different ways that we can create food products out of the seeds. Her work has been incredible. We've even been testing some of her food products in the lab, and that has been so much fun. I'm so excited to see where her work goes. And finally, we move on to PhD student Clayton Moore. He's been working on different medical aspects of cannabis, not only with trying to find different compounds in the plant that can help humans, but seeing how we can change cancer treatments and how different phytochemicals in the plant, not only cannabis, but other plants, can revolutionize our medical industry. Now, Dr. Russell Jessup has been making all of us so encouraged and so inspired to work on this plant. He's always encouraging us to find different ways and different research that we can combat to use this plant not only as an agricultural plant to feed our humans and animals, but also try to figure out how we can alter our planet in a positive, revolutionary way. I always found something with Dr. Jessup is that he's always encouraging us to find what we are passionate about. We are never bored in the lab. He always has us doing something. We are always so happy to be there just because he is very enthusiastic about everything that he does. Working in the Industrial Hemp Breeding Lab has been an amazing experience. We have been doing a lot of different work, not only to help the humans, help animals, help the plants, but the earth as a whole. And now I'm going to switch off and start introducing some of our speakers today. We have Clayton Moore. He's been working on the medical side with cannabis. We have Joshua Van Dyke, who's been working on the industrial fiber. And we also have Ian McGrath, who's been working on a natural pesticide from plant compounds. You can go ahead.
Yeah, sure. Hi, my name's Clay Moore. I've been in the Industrial Hemp Breeding Program since the summer of 2021, along with these great individuals, and especially the ones in the crowd today. I'm an 8th generation Texan and a 3rd generation Aggie, so I haven't gone anywhere. But for the past 3 years in the Industrial Hemp Breeding Program, I've been working on a project called the Hemp Conversion Program with the assistance of Joshua Van Dyke, Dr. Jessup, and I getting a USDA ARS grant for $250,000 to increase diversity among hemp's varietals in the United States of America. I was able to, over these 3 years, source 126 varieties from over 14 different countries. And we take those varietals and we breed them with our federally compliant under the 0.3% THC threshold, as well as Texas and Southern coastal adapted hemp varietals. And we're actually releasing a variety to USDA within the next month or so, and more to come from those as well. And that was my undergraduate. I just graduated in May and I just started my PhD. Because I was so focused on the phytochemicals in the breeding aspect of keeping the below 0.3% THC, the idea was diversity. So I was working with varietals that had high CBG, high CBD, high CBC, a lot of Varin strains. So that interest in phytochemical got me into wanting to go the medical route. And so my PhD, I'm focusing on developing medicines from phytochemicals, specifically in hemp, but also all other plant sources. We're trying to develop novel delivery systems for these drugs as well, and a lot of computational AI regenerative knowledge as well. So Yeah.
Hi, my name is Joshua Van Dyke. I'm from Humble, Texas. I got my undergraduate here at Texas A&M in molecular biology, and I started working here in 2021 in Dr. Jessup's lab. I study fiber and its uses. So if y'all don't know, hemp has two kinds of fiber in it. One is a long kind called bast, which is used for clothes and stuff like that. The inner kind is shorter. It's called hurd, and there's not as many uses for that. This inner short fiber, though, composes about 80% of the plant, and it's usually just discarded. So my work is trying to find different ways to use it. And my favorite personally is a product called nanocellulose. It's basically fiber that has been broken down into pieces so small it can't even be seen on a microscope. And that has a lot of interesting applications as plastic, concrete strengtheners, and an emulsifier. So in conjunction with Ian's terpenes, we could have a 100% plant-based pesticide one day using this emulsifier. My other research is kind of like how we analyze fiber. So that inner fiber, one of our big project is breeding it so that it can have longer inner fibers so that we can make more paper out of it and use more of the plant. So I go and I've developed protocols to measure the fibers grown by our head breeder, Zeke. Say hi to everyone. And I'm also Chris, and we can confirm the herd's length and phenotype it that way.
Hi, everybody. My name is Ian McGrath. I graduated with my bachelor's in plant and environmental soil science back in May. I've been working with the industrial hemp breeding program for 3 years. And my work, as you've heard a little bit, is making an organic pesticide out of terpenes and organic components. We're really trying to make food and cannabis safer. There's a lot of concerns fairly consistently in the media about pesticide residues, synthetic chemicals that we're consuming small amounts of on a daily basis. So in the cannabis industry, in the concentrates in particular, a lot of these pesticide residues can be concentrated, and with that, all of the synthetic, potentially cancer-causing chemicals, right, that could hurt cannabis users. So my work has basically been establishing the phytotoxicity limits of different terpene isolates on cannabis and other crops. We're trying to find the amounts we can spray on plants. So when we find uses for these chemicals, for terpenes, whether they're for insecticidal use or fungicidal use, we can then go ahead and utilize them and put them into commercial products. And in addition to pesticides, you can also potentially have terpene steering, is what I call it, because the plants respond to different environmental pressures. They can actually sense terpenes in the air. And so if we spray terpenes onto a cannabis plant, we could theoretically steer the terpene profile. And that has uses in the medical cannabis space, as there's been a lot of interest in terpenes and their different values for different conditions. And so I've done a lot of pest screening for a formulation that I made. We're calling it W3 internally, and we're working on commercializing that and collecting more preliminary data so we can move towards EPA approval and eventually get this on the market. And yeah.
Thank you so much, Clay, Josh, and Ian. I wanted to open up to the audience if you guys had any questions for these guys. I know I've got plenty of questions myself, but they're open to whatever you guys got. So if you have a question, please raise your hand and I can bring the microphone over. Oh, thank you.
You did say, Clay, that you were doing variants. Are you guys doing variants in the lab?
So, in terms of medical, I mean, nothing, but we've had one THC Varin strain that we've had in our hemp conversion program as well. But as of just one varietal, it was labeled banana strawberry, I believe. And this was actually sourced from a breeder in Texas.
Okay. Sourced. I'm just curious because, I've, talking with people, the varins are really difficult to cultivate.
Mm-hmm. Oh,
So
yes.
like, are you seeing that kind of thing too? Like that needs to be grown from seed, not from clones?
So we never grew them from clones. We're always in seed. So basically, the hemp conversion program utilizes Ezekiel Soto's inbred lines as well because we want to always start from seed. But one thing that we noticed with this Varin strain, it's very apt to hermaphroditing. So becoming Monishi, where if you grow females, it'll pop male flowers on it. They stress very easily is what we found. But clonal propagation, we've not done any clonal with THC-V strains.
Okay,
So,
cool. Thanks.
Yeah.
Other questions from the audience? Yes. Sure.
So my question's for you, Ian. You said that you were doing research on the terpenes for pests. I was wondering if you did any research for the insecticidal properties of different cannabinoids like CBD or CBG.
So I personally have not. Most of the research that I've read shows that there's not really a lot of insecticidal activity with cannabinoids. Most of the pest resistance is probably the terpenes and potentially some of the other compounds. But yeah, I have not looked at.
They're way more expensive than terpenes too, right?
Not necessarily.
Oh, okay.
Yeah.
I asked because I did some research with CBG out at CSU, and we found some insecticidal properties of CBG. So I was wondering if y'all did any of the same studies here.
Did you really? I'd be curious to know what pests you found.
It was the tobacco hornworm, so we tested it on.
Okay,
We
interesting.
found it. It essentially made their shell when they were turned into moss hardened too much and it just suffocated them. Yeah.
That's fascinating. I know there's a lot of debate still about what really the cannabinoids do for the plant in terms of being able to survive in the environment. There's some people who think that it's herbivore resistance. Some people think that it's insecticidal resistance, and potentially other things like environmental tolerance.
Well, thank you.
So Texas A&M is known as a very conservative institution, and I wonder how the reception has been to this hemp breeding program with faculty, leadership at the university, and with your fellow students.
It's been pretty accepting. I'd say the vast majority of students' stance on cannabis is just indifferent. And there's like a very small percentage that does not like it, but they're dwarfed by the people who do. So we've gotten pretty good reception. We've got a lot of support from our program and all that.
Mm-hmm. Yeah, and in terms of Texas A&M as well, it's actually decriminalized on campus just recently. The chief of police of A&M, not College Station, but A&M has decriminalized it. They came out and said we shouldn't be arresting these students. They come from states that are legalized or have been legalized for a while, and they have product on them, and it gets them in trouble in Texas because they're not familiar with laws. Even the Chancellor John Sharp went on to say that he also thinks it's ridiculous that possession people should be put in jail. But in terms of College Station is more against and for arresting. I think it was 600 people in
Yeah,
College.
there's 600 people every year in College Station alone.
Yeah, are arrested for possession charges every year. Yeah. So.
And these are low level. This is below 2 ounces.
Yeah.
Yeah.
But not only our students and our police officers, we've also had our faculty be pretty supportive of cannabis. We were even able to develop a student organization on campus through Soil and Crop Sciences known as the Cannabis Hemp Innovation League, also known as CHILL. We've had outpouring support for this club, especially from Dr. David Spaltensberger. He's really helped us form this club and grow it to what it is now. We've even reached out to other department faculty, such as in engineering, food science, business, horticulture, really all over the place. And we've had numerous positive outreach from not only students, but from faculty. We've even been able to reach outside Texas A&M and had outside speakers come in and other people who are interested in it. So as much as we have had some backlash, the amount of positive support that we've got is overwhelming. So it's been really great.
Yeah, in terms from department to department, MJ did a great data collection on our very first ever CHILL meeting when we had over 120 people attend. There was over 51 different majors in diversity, anywhere from horticulture, pre-med, nursing, engineering, neuroscience, political science. And so in terms of our outreach, it seems like there's students in every department that has some kind of interest or is pro-cannabis. So.
Hey guys, this is Liz Grow. I just want to always give you guys a shout out for the work that you're doing. You are the future of cannabis in this country as I see it, but certainly the future of cannabis in Texas. So thank you for all of your hard work and dedication, Clay. Congrats on your recent graduation and thank you for continuing your studies. Oh, do we have another? How many graduates do we have on stage?
MJ and Ian and Josh is graduating soon.
Okay.
Yeah.
Congratulations to all of you guys. Congratulations to all of you guys. Well, my question, I'll keep it brief. How do you think that your research work or your work just in general has done to affect our lawmakers' mindsets about the plant? Do you think that your work has gotten to them? Do you think that they know that there is a student organization at Texas A&M that's working on behalf of this plant?
So in terms of lawmakers knowing about CHILL, I'm sure it's very minimal. I'm not aware of any lawmakers that actually know about CHILL. And so one thing that would always be open to discussion on making a trip to the Capitol as CHILL, that would be a great opportunity to get young people in the Capitol that actually know what they're talking about and can actually articulate what it is that we're doing at Texas A&M to these policymakers. It seems that there's a lack of knowledge and a lot of advocacy, and the advocacy sometimes can outweigh the knowledge. And so it's hard for some advocates to articulate to the lawmakers to make it more simplified for them to understand. So, yeah.
So recently, I'm a dental hygienist, I said earlier today, but I had a patient who is working on her graduate degree in neuroscience here. She said that they're doing TBI research, and cannabis is one of the things that they're looking at. And so she hadn't heard about this conference. I told her about it, of course. But do you guys collaborate on any level with these other departments who are doing this? And what does that look like?
So for this, no, we don't collaborate. And this medical has just started. I'm the first student doing medical cannabis research in our program. And then the health department at A&M does know a lot about cannabis and cannabis research, but they're just not doing it. They're not allowed to do it because they don't have teacup collaborations, and there's a lot of red tape. And then some people are just too scared to actually start doing the research. But in terms, I never even knew that the neuroscience department was studying cannabis at all. And so that could also be another thing, is that departments sometimes are competing against each other, and they don't like to tell other departments what they're doing so that they have better foot up on grants such as National Science Foundation or NIH as well within A&M. And so that could also be a potential why we don't know that they're studying cannabis.
Outside of the medical side, though, we have worked with other departments. I know we've worked with horticulture a lot, and we've had a few engineering students too work with us. So we've collaborated with other departments, but we're mostly working with other people in agronomy.
Mm-hmm. Yeah.
Is it working? Yeah. Hey, so I just wanted to ask you each briefly, what's something about the plant? Why are you passionate about this plant? And what about the future is exciting, because of this research, because of the things you are doing? What drives you?
Ian, I'll let you take this off.
What got me interested in the plants? Well, so when I became a teenager, I started having, depression and anxiety and things like that, and had pharmaceuticals prescribed to me for a number of years. And the amount of side effects that I experienced with those was just too much for me to handle. And so when I became an adult, I kind of found cannabis, and it helped me in different capacities. And I thought it was really interesting that a plant could produce just a valuable chemical for medicine, right? And that plants could be medicine, or they could be poison, or they could be food. And I always had a big interest in chemistry, and cannabis produces a lot of very interesting chemicals that are underutilized and even demonized. And so I thought that was a unique challenge for me to pursue, a tough nut to crack, So that's kind of the story with me.
So when I was in molecular biology, I primarily worked with bacteria, and bacteria are kind of boring because you don't really if you make a mutant bacteria, you don't it doesn't turn purple or anything cool. You don't really see what you're doing with it. So plants were interesting because you can see the effects of what you're doing. So I slowly moved over there, and then cannabis was a brand new thing that we had just started researching here. So I jumped on it, and this program's been great. It's a lot of other labs are very rigid and dogmatic, but everyone, Dr. Jessup especially, he encourages creativity and kind of just freedom of thought. So it's been interesting working here.
I can't say that it was just one thing that struck passion with me, but accumulation of a lot of things that this industry has showed me. So personal anecdote, I lost my father to suicide from overuse of antidepressants, different steroids, opioids, and really hard prescription drugs to help him battle various things. And then it kind of just tipped over. And one of the things I wish he could have been put on for his depression and anxiety was cannabis. And then I'm a big supporter of veterans. I support the Warriors Weekend chapter in Victoria, Texas every year, and in memory of vets that we lost, and also the current vets that we have, and people on active military, and how cannabis helps them with PTSD or any pain that has been caused to them while they were in the military. And then also the introduction to this industrial hemp breeding program. I started actually my freshman year at A&M Kingsville and was introduced to Dr. Joshua McGinty, who took on a Rare Earth Genomics sponsored grow across Texas that hit 5 different locations. And I was lucky enough to be at one of the locations and met Dr. Jessup in the field, found out that I got accepted to A&M, and he hired me right then and there. And ever since then, I've just had a growing passion for this plant. So, yeah.
So I think we all kind of share the same passion for the plant, considering the fact that it has so many different uses in not only helping humans, but helping the entire planet. Something that really kind of connected me with this plant was that throughout high school, I wasn't quite sure what I wanted to do. I looked at different aspects of what I could do, what could make me, to put it frankly, money in the world. But I also wanted to do something that would make a change. And Maryland legalized medically cannabis in 2015. And they also offered the opportunity for citizens to grow one plant on their property. I took full advantage of this. In my garden, I had plenty of plants as well as a cannabis plant. I just fell in love with the plant. I thought that it was so beautiful, so neat. And as I started looking more into how not only it can help us medicinally, but it can also change our entire world. The way that this plant has been scrutinized since the 1930s and its opportunities to overcome our plastic use, our timber use, fossil fuel use, I found that this was a plant that I can actually make a change. Not only help myself with its properties similar to what Ian had experienced, but as well as actually do something that can not only help myself, but help my fellow peers and help the environment. I just wanted to find something that I could actually be inspired by and think that I can make a change that's positive in the world. And so that is what really brought me to this plant. When I came to A&M, I had no idea that we had a hemp program here. I came to A&M because it's one of the best agricultural schools in the country. And then I was told by my advisor that we had the industrial hemp production and utilization class. So I took that. I was introduced to Dr. Russell Jessup. I actually took that class with Ian, and that's how I started my career here. And ever since then, my love and passion for this plant has just grown infinitely. So it has been honestly amazing to be able to work with this plant. Thank you, Mason. And anyone else have some questions?
I have a question for Joshua. You mentioned the two types of fiber that come from the plant, the bast, which is like the fiber on the outside, and then the hurd on the inside. But there's fewer uses of the hurd than there are for the bast. Can you talk about some of the products that you can make out of the hurd versus the bast?
So right now they, a lot of people use hurd just as like animal bedding and stuff like that. There's some people are trying to make tissue paper out of it, but it's been pretty limited so far. There's also been hempcrete is made out of hurd, and some kinds of particle board are also, but those are also I think plywood can also be hemp bast instead. So it's mainly just some kinds of paper can be made out of hurd right now, animal bedding, and some kinds of particle board. So it's not a lot right now, but it's very big fiber feedstock. So it's something that if we could get it a little longer, like maybe 0.2 millimeters longer, it would be really viable for paper making and a much wider variety of paper than just tissue paper that's being used for now, like cardboard boxes and things like that, like, where it can really make a difference in the market.
And how about out of bast?
Out of the bast, bast is actually great for pretty much everything. You can make clothes out of it. It's a little rough. So like the clothes, it's not as popular as it used to be. But the big thing that bast is made out of in a lot of places is paper. I know in France, they make a lot of their money with hemp bast, and a lot of specialty papers are made of it. And they also have it for industrial stuff like ropes and bags and things like that.
So I have a question for Ian. What about your terpene pesticide comparative to traditional chemical pesticides? How does that affect the environmental impact and its overall effectiveness?
With our formulation, so one of the most unique things about it is that we emulsify it with cellulose. And so using Josh's methods, we can get enough nanocellulose to emulsify the terpenes, which are kind of an oily-like substance, right? You can't directly mix it with water. So by using cellulose, we can get the terpenes and the water all into one diluted solution. And you can do it without a petroleum-based or semi-synthetic emulsifier, which is typically used even in organic pesticides. There's a lot of semi-synthetic exclusions that are actually allowed in organic products, and companies do it because it's cheap and because the EPA allows them to. So we can actually offer a truly organic product by emulsifying it with cellulose. And then there's other components to the pesticide, which gives it a sort of layered mode of action. So we can target sort of all of the different systems in the insect itself. Instead of just targeting one system, we can go after multiple. And by using several different terpenes, we can kind of do that. By using other components like seed oils, we can do that. And obviously the residues are less of a concern, because when you're talking about other synthetic pesticides, right, that are synthetic and potentially harmful, whereas we use terpenes, which are actually found in our diets, right? It's in essential oils, it's in oranges, it's in rosemary, it's in things we eat every day. It's the plant's natural defenses. So we're basically harvesting the plant's natural defenses. We're putting it in a bottle and we're letting people use that. And so, you know, there's much less concerns about harm to us, much less concerns about harm to the environment, persisting residues. A lot of these terpenes are also very volatile, so they are sprayed on the plant, they evaporate off, and so there's really nothing left there that would be of concern. So those are kind of the different benefits to our formulation compared to pretty much anything you can find on the market right now.
Thank you so much, Ian. We have a question in the back, if we can do the microphone.
So again, for Ian, a little more specific and technical. Have you found specific terpenoids from cannabis that target the octopamine receptors?
I have not looked into that. I would be very interested to discuss that with you.
Yeah, we'll talk later.
Thank you so much. I have a question for Clay. How did you prioritize plants to choose finding anti-cancer properties?
That's a good question. I looked at previous data on known antioxidants that also do anti-cancer. Some of our chemotherapies, like paclitaxel, is a diterpenoid that actually is a microtubule stabilizer. And this is something that you really don't want to, this is last resort chemotherapy. This isn't something that you want to do for preventative cancer or attack it when it's little, but basically it's a microtubule stabilizer, which causes the cells to stop dividing, and specifically cancer cells. But the issue is that it also targets neighboring healthy cells, and it specifically targets rapidly dividing cells like your gastrointestinal cells and your hair follicle cells. So that's why when you see people go through chemotherapy and they're getting paclitaxel, they have awful nausea and they lose all their hair. Paclitaxel is from the yew tree in Asia. There's various phytochemicals. I mean, there's nicotine, there's poppy, there's various chemicals that are being utilized right now. But we think that there might be phytochemicals in hemp and some other various plants that just aren't being looked at. There's not a lot of potential candidates that have been found specifically at A&M with phytochemicals, but we have previous data of all the other drugs that have been developed. We have a very large drug bank that we can revert to. And so what I had mentioned earlier is that I'm looking into AI regenerative models. And so we're going to take all the previous drugs, scan them, and then enter in phytochemicals as we go, and then compare them and how the binding affinity to whatever the cancer might be. But more specifically on the antioxidant is very interesting to me, like such as anthocyanins are very antioxidant. But yeah, mainly just plants are interesting because they haven't been looked at in terms of phytochemicals for, there's a lot of unrepresented plants as well that haven't been looked at, so.
Awesome. Thank you so much. This question is for Josh. Are there any challenges that you found trying to utilize cannabis fiber in replacing plastics?
So, yes, kind of. So nanocellulose is very hydrophilic, which means it likes water. So it likes to be in water. The problem with it doesn't replace the plastics, it reduces them, so it makes them stronger, makes it so you don't have to use as much. But plastic is a very hydrophobic substance, especially the resins. So, you know, they don't like each other. So the nanocellulose doesn't really integrate in a lot of kinds of plastic very well. And one way I've tried to combat this is to do what's called emulsion polymerization, where it's basically you suspend a plastic in water and you get nanocellulose in there, and you use nanocellulose as the emulsifier to kind of like wrap around all those little droplets of plastic resin. And at that point, you can make lots of different latex products that contain nanocellulose from hemp. So one really common one is latex paint. So it could be in latex paint and things like that.
Awesome. Thank you so much. If there's any questions, please raise your hand because I'm just going to keep on firing questions to these boys. Ian, I've got one for you. How do you think that your organic pesticide could potentially be integrated into other sustainable agricultural techniques such as companion planting and IPM?
There's a lot of interesting ways we can use terpenes in products. Essential oils have been kind of used in pesticide products for a while. And by really refining our formulas and going down to specific terpene isolates, we can look at the very specific ecological roles that they play in plant communication and insecticidal activity, fungicidal activity. And we can really use them to get the plants to do more of what we want and less of what we don't want. And remind me the second part of your question. Was it the effects on the environment?
Companion plant planting and integrated pest management. Yeah,
so we can get really specific with some of these terpenes and the insects that we target. The plants learn to produce these new compounds as they evolved to target specific pest pressures that they had. So if there's a caterpillar problem, for example, we could screen the entire library of terpenes that are available to us, of which there are thousands. In cannabis alone, there's over 150. And we can breed new varieties of cannabis, for example, that express these terpenes for specific pest pressures and specific environments. We can take those terpenes and we can put them into products that we could apply, particularly in indoor and greenhouse settings. They would be very effective and fairly economical. Getting into outdoor use patterns, you start to run problems with like evaporation, where the compounds would likely evaporate before they can actually serve the role that you're looking for, because the residue action with these compounds is very small, which is part of the strategy, right? That's kind of what we want. We want low residues. We want high effectiveness against the pests. And we want to have minimal impact on the environment and on our health. So there's a lot of different ways that these terpene pesticides could be used to our benefit.
Thank you so much. I'm going to switch back over to Clay. What made you transition from being a plant breeder and grower to working on the medical side of things with cancer?
Well, to be fair, I actually was a pre-med before I switched into plant breeding. And so I've always had an interest in medical side of things, and bringing the two together is kind of beautiful in a sense, being able to convert what Earth gives us to heal people and everyone in this room. And so that's always been kind of my interest, is in the medical side. So besides going to med school, I can do my PhD and develop medicines and work with other medical doctors to potentially prescribe these later down the line when FDA approves. So.
That's very inspiring. That's awesome. Back to Josh. What have been some supply chain issues that affects the fiber industry? Like, why can we expand on our current fiber uses?
So first problem, probably the biggest, is hemp fiber needs to be decorticated. And there aren't a lot of decortication facilities around the country right now. They're growing and there's more, but there aren't very many in Texas. So there's equipment that people need that they don't have. And since hemp was illegal for so long, they kind of stopped making decorticators for a while, and they're starting again. The other problem is for things like paper making, hemp requires some changes to the process that it doesn't really have a large enough supply that like pulping mills are willing to make those changes for hemp. So cost is definitely an issue. And for my research personally, like just getting hemp pulp has been almost impossible. I've had to do it all. I've had to make the hemp pulp myself because there's just nowhere to get it from right now. But I think as more people start growing and different regulations loosen up, I think that hemp fiber will become way more viable.
Thank you for highlighting some of those issues. It's definitely been frustrating just to hear from your own research and as well as other decorticators and fiber workers around the country. Transitioning back to Ian, throughout your research with the pesticide, what plants have you been able to experiment on to see your pesticide's efficacy?
So we've screened, I think, 8 crops so far with a larger list that we're going to start experimenting on soon. So far, we've done hemp, cannabis, obviously, and we've done tomatoes, eggplants, lettuce, kale, squash, and a few others. And so they have kind of mixed results. We've done corn as well. So we found that grass species are particularly vulnerable to it, just based off of physiology and where the droplets from the pesticide can sit, versus broadleaf plants tend to be fairly resistant. Also, plants that have waxier leaves can tend to be a little more sensitive to the formula. But the most promising things have been that it works really well on some of the high value greenhouse crops, which is really where the impact is going to be. Things that are fairly commonly sprayed with some of these nastier synthetic products, things that have higher pesticide residue concerns in the supermarket. So things like tomatoes and eggplants, lettuce are all very tolerant to it. So it should be highly effective. The dose ranges that they seem to tolerate exceed the dose ranges that are very effective against common pests like aphids and spider mites. We've seen 90% mortality rates off of a single application. And just with a few applications, I mean, you can do the math. It's fairly effective, it seems to be. So we're pretty excited about the impact that it could potentially have.
That's fantastic to hear. Thank you for sharing. All right, back to Clay. What challenges do you foresee with using these novel phytochemicals, especially in a state such as Texas, where cannabis is under such scrutiny and regulation?
Well, we have to hope that they work. But in terms of regulation, I hope that Texas opens up more, but as of right now, I'm limited on my phytochemicals. In terms of cannabis, I'm limited to the non-psychoactives and more the hemp-derived cannabinoids. But besides that, I don't really have any limitations on what it is that I can research. One of the nice things that I'm working on is I'm building a high throughput per se system where people will be able to come in and work with us. If they have a formulation that they would like to get data retrieved back, we can run cancer cell lines for them and give them that data as well. We can run computational analysis and predictive analysis to get you binding affinity, and we'll even one day be able to give you expertise on how you can modify your formulation to help us. So in terms of being held back, I think we're only held back by marijuana, I guess, in terms of THC. So
well, hopefully it becomes easier to research these chemicals.
Definitely.
Oh. All right, Josh, I got a question for you. Have there been specific challenges trying to work with the consistency and quality of bast and hurd fibers throughout your research?
No, there haven't been any major problems with the fibers themselves. Okay, so we used to not have, so now we have giant bags of bast and giant bags of hurd. We used to not, so I used to have to in trash cans hemp and then hand peeled the bast off the hurd so that I could only have hurd fiber. This was years ago when we first started.
It was very.
It smelled like sewage, and it was terrible. And they banned me from ever doing that again. So that was a huge challenge. But now we have more connections, so we have tons of bast and hurd. So the problems were more mechanical, like separating it and things like that. But we've worked through a lot of those now.
Yeah, thanks to Roger Palomito giving us a huge donation of hemp fibers. That was very helpful. So,
thank you. And yes, that hurd and bast redding was gnarly. For Ian, what can we expect for the timeline of seeing your terpene pesticide reaching the market?
So we've done a lot of work with EPA consultants. We have kind of got an idea of the data requirements that the EPA would like fulfilled before we can get the product approved and on store shelves. It's quite an extensive list. It's quite an expensive list. So I believe we're sort of trying to design some of our next experiments, collect some of the funding necessary to get that going. And I think it's probably about a year of EPA data collection. It's about a year and a half at a minimum for the EPA to review an application and potentially approve it. And then you're looking at another 6 months to a year just to get it approved in the individual states. Because you have to go for federal approval, and then you have to go and get state approval in each state that you plan on selling it in, or even if your truck is passing through that state on its way to its destination, each of those states along that path have to have your pesticide registered. So each of those comes with a fee and a timeline. And so we're looking at probably 3 to 5 years before this is going to be on store shelves, available to consumers, and potentially a little bit sooner than that. We would be partnering with different growers to trial it on larger scales. So that's kind of what that's looking like.
It's unfortunately how many hurdles you guys have to go through just to get this to market, but I'm sure we're all very much eagerly anticipating when it actually reaches. Thank you.
I have a question for you, actually. Ooh. With your current research, can you explain the importance of petiole propagation and the difference between branch propagation and petiole propagation is?
Yeah, thank you. So petiole propagation kind of goes into, so if you're looking at the plant, and if you look at any leaves, particularly the fan leaves, you have your very broad leaf, and then you have a stem, a little skinny stem that connects to the actual stalk of the plant. This is known as the petiole. Traditionally in clonal propagation, what you'll see in the industry is that growers will cut off whole stems of the plant to use for propagation. And doing this can actually decrease the biomass and how large your plant is. This can be extremely damaging to what we see with mother plants, and even take a longer turnaround time to produce more clones. And when you do this, you are, like I said, you're taking off a lot of biomass. You're going to have to take a while for that plant to regrow. Exploring different ways that we can propagate by using petioles. Many people in the industry already defoliate their plants. They'll just remove leaves to try to increase canopy air, as well as light penetration into that canopy. When you take those leaves off the plant, traditionally people either throw them away or use them for compost. What I'm proposing is a novel idea that we can take those leaves that we are defoliating off the plant and use those for clonal propagation. We have actually been able to produce roots off of these. We are starting to work on trying to get them to produce new shoots. But if we're able to develop this, it'll be a novel way and a more efficient way that we can do clonal propagation on these plants. Because not only are we keeping the biomass of the plant, but the plant can regrow leaves much faster than it can regrow entire stems. So if we can do this, we are optimizing and making the industry more efficient. Thank you, Clay.
Yeah, it almost seems like a no-brainer that, comparative how many leaves are on a plant versus how many branches are on a plant, you can get way more clones, meaning you'll have less mother plants. And so that's less space that you have to take up. So,
well, hopefully we can get that paper published soon and then get the industry going on this. I'm going to flip back to you. I got a question. How do you see plant-derived cancer therapies integrating into mainstream oncology in the future?
It's interesting. It could either just be like any other drug is developed and entered into the world of pharmacology, but there's a lot of controversy behind big pharmas getting involved with scooping up these people that are creating novel plant molecules or novel plant compounds. But I don't think it'll be any different besides having to go through all the FDA regulations. There's other ways you can get to it by working with Canada or Europe because they have some faster paced steps. There's also orphan drugs you can go through. So if you have a hit on a phytochemical that you think can cause some rare disease or fix some rare disease, you could end up getting a fast track that way. But integration, I don't think will be any different from making just regular synthetic drugs. So.
Well, I can't wait to see that in our medical programs. I'm sure a lot of us have family members or know people affected by cancer. So if we can find a way that is a revolutionary method that can also be derived from plants and a plant that we love, cannabis, that'd be amazing. We're getting close on time. We got 4 minutes left. So I'm going to ask the boys a couple more questions and then we'll cut it off. Josh, how does our U.S. fiber compare to other fiber production in other countries, such as in Europe or China or Canada?
Do you mean the plants or like?
Just the fiber industry as a whole. How does it compare?
So, Europe and China, they both have bigger fiber markets, and they also have varieties that grow better in their climates than we do right now. So a lot of the heat tolerant varieties like Jinma and different Chinese plants, they grow well here, but they usually test hot for THC. And when I say hot, I mean like they have like 2 or 3% THC. So the issue is we can't use those plants for fiber, so we have to go and get European plants. The problem is like in the Netherlands where they're grown, that's totally the wrong climate for Texas, even though it has low THC, they don't grow well here. So the challenge here on the growing side is how do you get the good fiber traits from the Chinese stuff and the low THC from the European stuff? And that's actually Zeke's research. So that's been a challenge. That's probably the challenge for cultivation. On the industry side, America's just very spread out, and we would need a lot of decortication mills to probably actually serve enough of the fiber growers that could potentially arise. So those are the big challenges there. And then also that short herd. Yeah.
Well, thank you so much for comparing and contrasting the two. I'm really hoping that we can get our U.S. fiber industry up and running. Final question for Ian. What made you start to research terpenes as a pesticide?
So when I first got the job in the industrial hemp breeding program, I was offered a list of 3 different projects. And I'd kind of known what terpenes were. And I saw the word terpenes and I picked the project, and I didn't think about the fact that I'd also have to grow bugs. So I turned into bug boy at the lab. I had and have no interest in bugs. Killing them is fun. It's a good skill to have. And so that's kind of how that happened. I picked it from a list. I was interested in the chemistry of terpenes, and I became bug boy. So,
well, we all call you that very affectionately, and we're glad that you keep them isolated to your bug room.
Yes.
We have 1 minute left. I didn't know if anyone else in the crowd had any questions before we have to call it a day here.
I think we can do 3 questions in 1 minute.
Probably not. But I want to thank you guys so much for being up here on this panel and talking about your research. It is amazing to watch you guys work in the lab and just hear by either direct conversations or side conversations on how your research is doing. I'm sure we are all very excited for how your research is going to come out in the coming years, especially with Josh graduating with his PhD soon and Ian, Clay, myself just now starting our PhDs. Thank you guys so much.
Yeah, you're welcome. I did want to say kind of like a closing quote that I thought of literally just this morning. Kevin with the advocacy was talking about how the cannabis industry and whatever industry you're in is a marathon. It's not a sprint, that it's a war we have to win, not just single battles, but ultimately the war. And A&M has a great saying that if you give me 10,000 of the greatest West Point graduates, will win the battle, but if you give me a handful of Aggies, we'll win the war. So that's what I think this group is all about. Yeah.
Very well said. Thank you, guys.